Hello everybody, well CES 2022 is here and finally Sony officially announced the PlayStation VR2. As you can see, this is the logo and we got plenty of information actually on the official PlayStation blog. Some really spicy details and of course hardware specifications. We also read about upcoming games for it. We're going to talk about this a bit later. But the most important thing, of course, is taking a look at the hardware specifications. Sony also tweeted about it, mentioning, you can see here, Sense Controller, 4K OLED display, single cord setup, guys. This is crazy, and more. And this, of course, linked to the official blog. So basically, we're going to have just the USB-C connector connecting to the PlayStation 5. So no more of this complex setup compared to the PlayStation VR, the original one. Now, there's also inside-out tracking, same as the Quest 2, so no need to external beacons or cameras, just gonna track everything from the inside out. The field of view, as you can see, as mentioned here, is slightly higher. I think it was 100 degrees on the PlayStation VR 1, and here it's 110 approximately. The refresh rate, by the way, is 19 and 120 Hertz. By the way, this is the same as the original one. Resolution increased. Now we have, as you can see, 2K by 2.04. This is 4.1 megapixels per eye with an OLED display and HDR support. Crazy. They also implemented eye tracking built in the headset. This means that the headset can actually track where you are looking at. Keep in mind, this will be available for developers as an API, so they can track the angle of where the direction or probably a vector where you are looking at and use it in their apps or games. Just an example, for if you look at a certain, maybe a monster into the eyes, they can look at you back. And maybe if you look for the side, you won't get a reaction. But if you look directly into the eyes, will be a reaction. You can make it so if you look at certain direction, the focus of everything will be on a specific object you are looking at, and the other ones can appear blurry. You can even use it for UI. When you're looking down, then just something will continue to scroll down as you read, rather than you need to use, for example, the stick to scroll down a specific window with text. I mean, there's so many ways to implement this in games, and I'm sure developers will come up with some really original ways to make games and apps more immersive, fun, and intuitive to use. This just brings things more closer to the real life. For example, if I'm sitting in front of a person, I'm looking at the side, the person can tell me, well, can you please look at me, right? But the thing is, in VR, when you want to create something more realistic, you need to be aware of so many things that happen to the human body. And eyes, of course, is one way, one of the most important way when you communicate with others. So this can really be used in a way that otherwise we couldn't do when we use some kind of interaction between the player themselves and other characters in game. But as I said, there are plenty of ways to use it, and we need to see what developers will come up with. Keep in mind that alongside Foveated Rendering, if you use eye tracking, you can actually optimize the performance even better by making sure that where the players are actually looking at, not just at the front. For example, you're looking, for example, at the top left corner, some of the assets of textures and the resolution of the 3D models can be reduced to improve performance, and only the areas where you're looking at will actually appear sharp. Until now, for example, like the Quest 2, Foveated Rendering was used to render sharp visuals at the center where players are looking at, and it wasn't able to do a more complex computations and optimizations because there wasn't built-in eye tracking compared to what we have right now on the PlayStation VR2. So we can expect many of other VR headsets in their next generation to have eye tracking sensors, again, mostly to do things like optimize the foveated rendering, smart UR navigation, and of course in-game interactions. Now, this is from the official Oculus.com website. As you can see here, Oculus Quest fixed foveated system is not based on eye tracking, right? So you don't have the dynamics of the foveated rendering working in relation to the eye tracking. This is not available on the Oculus Quest and Quest 2 VR headsets. And when they mention dynamic, just at the top paragraph, they mention this is in relation to the GPU. So, if you need more GPU power, it can dynamically reduce the details in the edges of the field of view in order to maximize performance. Now, this feature is not new to VR headset, but usually more enterprise VR headset has this, not consumer ones. So seeing this available on the PlayStation VR2, this is a really, really great feature. And if I'm not wrong, this is the first consumer VR headset to actually adopt this technology. Now, keep in mind that if you own the PlayStation 5, you bought it, for example, for Christmas, and you want to play VR games, just so you know, the PlayStation VR headset is supported on the PlayStation 5. It does have backwards compatibility. As you can see here, this is from the official Sony website. But you can also get faster frame rate because the hardware of the PlayStation 5 is better. So some of the games that are supported will run at higher frame rates. Now, I also try to compile the data here to show you the differences between the PlayStation VR2, PSVR, the original one, and Quest 2. Regarding, by the way, the field of view of the Quest 2, based on the HMDQ tool, that's what it said. Some actually mentioned this is around 98 degrees, the original field of view, plus minus 4 degrees. Anyway, this is, I didn't get really the exact one. If you know, let me know in the comment section below, but let's take a look at the specs comparison. So you can see that PSVR 2 and PSVR 1, both OLED, Quest 2 fast switch LCD. In terms of resolution per eye, all right, you can see that the PSVR 2 wins here with the high resolution per eye. Refresh rate, as you can see, 120, 90, but as you can see, the Quest 2 does have experimental 120 Hertz. We can see that the PSVR has the 4 inside-out tracking with cameras, and by the way, this is similar to the Quest 2. Regarding connection, you can see that the Quest 2, of course, works untethered, but the PlayStation VR2, this is what we know here. I don't see that anything mentioned about being able to use it untethered, so it needs to be connected with the USB Type-C. If you know any other thing, let me know in the comment section below. And again, the Quest 2 can be connected using the VR link cable to your PC. Then you can use PC VR games and apps as well. In terms of audio, as you can see, built-in microphone and stereo headphone jacks available for all of them. In terms of feedback, the PSVR here has an advantage. Some say it can reduce motion sickness as well. As you can see, it has a rumble motor. In terms of tracking, inside out, the PSVR, of course, is different here. So again, no relying on any external sources to have the tracking. It's just built into the PlayStation VR headset. In terms of eye tracking, foveated rendering, you can see that it's available only on the PlayStation VR2 with fixed foveated rendering on the Quest 2. But again, it's not dynamic, not attached, not optimized furthermore with the eye tracking feature. Again, the eye tracking feature is available on PlayStation VR, and of course, it can be used in order to optimize the foveated tracking even more. And we also have HDR support as well, which is amazing. And we also have OLED display. So this is just optimal for HDR. So personally, I can't wait to see it. I have an HDR monitor in my room as well. So I know how amazing it is, especially when I play games with HDR on the PlayStation 5. So I'm sure it's going to be amazing. This also made me wonder about the differences between the two OLED display, between the PSVR and the PSVR 2. But I think it's going to be a better OLED, but I don't have any detailed information about that. But the fact it does support HDR, I think we're going to be looking at a better OLED display in general, but we need to wait and see more information about that. Now, regarding the haptic feedback actually helping with motion sickness, this is something that already been researched, and there's one research about it. You can actually check this link as shown here. So basically, we can have benefit from actually having this feedback available on the headset. There's also a video which talks about more in depth. So if you want to see, you can actually check this website and learn more. This is just a part of it.
Hi everyone, I'm Yihao Peng. Today I'm going to present Walking Vibe, reducing virtual reality sickness and improving realism while walking in VR using an unobtrusive hand-mounted vibrator feedback. This is the joint work with my advisor, Professor Nanhao Yu at National Taiwan University of Science and Technology, and Professor Mark Chen at National Taiwan University.
So yeah, so as you can see, it's not out of the blue. So they're talking about reducing virtual reality sickness and improving realism while walking in VR. So this is something I really looking forward to try. But the fact that we have this feedback means that we can have a more immersive experience, and also has the capability of reducing motion sickness. Again, I need to try it first hand in order to see how well it works, but and see, of course, what other people are reporting. But that's actually another great feature, so it seems. But you can see that the more people experience with VR, and of course there are problems to be solved in VR headset. It's not just about the visuals or the sound. There are so many other things because it's a different medium, and some people just don't get used to it. Some people have issues with it, and in order to be able to address those issues, many type of researches are being done in order to make sure that future headset will deliver a more immersive, fun, and comfortable VR experience. Now, this year, actually, PlayStation VR celebrates 5 years, and you can actually read more information about the amazing PlayStation VR2 Sense controller on the official blog. You can read more about the adaptive triggers, haptic feedback, finger touch detection, tracking, and more. So all these features come together, many advanced features both with the controller and the new headset, and everything, of course, will work together on the PlayStation 5 gaming console. And one thing I actually forgot here, but I searched for built-in headphones. There's no mention on about this on the official PlayStation blog. You just say input, built-in microphone, output, stereo, headphone jack. So again, nothing that Sony, I think, will forget to add. Although I did search for it on the web, and I found, for example, on techradar.com that they say that the PSVR 2's built-in headphones will also take advantage of Sony's 3D audio technology. So they said built-in headphones. So the thing is that I didn't find anything about built-in headphones on the official one. So this is something we're probably going to discuss in the comment section below. If you find more detailed information, let me know, because there are some contradicting information that I found. But on the official source, on PlayStation blog, this is what I see, what you see in front of you. Built-in microphone, an output, stereo headphone jack. So maybe we just need to connect a stereo headphone jack to be able to enjoy. Again, not sure about that. So if you know anything, let me know in the comment section below. So this is it for this video. Of course, I'm going to do more research and make sure to subscribe and give a like. See you on the next one. Thanks for watching. Cheers.